All right, today we're going to pull back the curtain on one of the most powerful tools in any modern business, the data warehouse. We're going to see how it takes that endless, chaotic stream of data your business creates and turns it into something with crystal clarity.
Look, every business today is practically drowning in data. Mountains of it. But here's the real question, the one that actually matters. Can any of that data tell you a compelling story? Can it give you the insights you need to make the big decisions? A lot of times, the honest answer is, nope.
And you know who the usual suspect is? It's your operational data. This is the stuff that runs the business second by second. You know, transactions flying through, customer info getting updated. It's built for speed and action, not for taking a long, deep look back at history. Trying to spot a trend in there is kind of like trying to read a whole book by just looking at one letter at a time. It just doesn't work.
And this gets us right to the heart of it, what we call the everyday data problem. It's all about this key idea, why running your business and understanding your business are two completely different things that need totally different tools.
So, if that's the problem, what's the fix? Well, this brings us to the data warehouse solution. Think of it as the hero that steps in to bring some much-needed order to your entire data universe.
So what exactly is it? The easiest way to think of a data warehouse is as a giant, central library for all of your company's historical data. Its job isn't to run the business day-to-day. No, it is built from the ground up for one purpose, to support smarter decision-making, reporting, and the whole world of business intelligence.
And what makes a data warehouse so special really comes down to these four foundational pillars first defined by the pioneer Bill Inman. First, it's subject-oriented, meaning data is organized around concepts like customer or product, not business processes. Second, it's integrated. It pulls data from all kinds of different sources and makes sure it all speaks the same language. Third, it's time-variant. This is huge. It keeps all that historical data so you can track how things change over time. And finally, it's non-volatile. Once data goes in, it doesn't get changed. It's a stable, reliable record of the past.
Now, the engine that powers all of this is a concept called Online Analytical Processing, or OLAP for short. If the warehouse is the library, OLAP is the super smart research librarian. It's designed to chew through massive volumes of data and answer really complex questions, the kind of stuff that would make your normal day-to-day systems just grind to a halt.
Admis table really lays out the two different worlds we're talking about. On the left, you've got OLTP, that's the operational world. It's all about speed, day-to-day transactions used by people on the front lines. On the right, you have OLAP, the analytical world. This is for asking the big, complicated questions, giving you a multidimensional view of the business used by analysts and executives. They serve totally different but equally vital purposes.
Okay, so now we know what a data warehouse is and why it exists. But how do you actually build one? That brings us to the blueprint, the very architecture of business insight.
At the core of pretty much every data warehouse design, you have two basic building blocks. First, you have facts. These are the numbers, the sales figures, the user counts, the quantities. They're the things you can measure. And then you have dimensions. These provide the context. They are the who, what, where, and when that give all those numbers actual meaning.
So how do you hook these facts and dimensions together? Well, by far the most common and, frankly, elegant design pattern for this is something called the star schema.
And yeah, it gets its name from its shape. It's actually pretty simple when you break it down. Right in the center, you have the fact table. This holds all your numbers and a bunch of special keys that link outwards. Then, radiating from that central table, like the points of a star, are your dimension tables. Each one holds all the descriptive context. One for time, one for products, one for customers, and so on. It's a design that's simple, fast, and incredibly powerful for analysis.
Now, there is a more complex version out there called the Snowflake schema. With this one, the dimension tables themselves get broken down into even more tables. So, for example, your product dimension might have its own subdimension for supplier info. This creates more and more branches, making the whole thing look kind of like a complex snowflake.
So really, it all comes down to a classic trade-off. The star schema is simpler. It has fewer connections or joins, which usually means your queries run a lot faster. But it can have more redundant data. The Snowflake schema, on the other hand, is more complex, with more joins, but it's really good at reducing that data redundancy, which saves you storage space. It's a choice between performance and storage efficiency.
All right, so we've got our blueprint, but a blueprint is pretty useless without the building materials, right?
So how do we actually get the data inside the warehouse? This is where we talk about the data supply chain.
The traditional, old-school way of doing this is called ETL. It stands for extract, transform, load, and that order is absolutely crucial. First, you extract the raw data from all your different systems. Then, you transform it. You clean it, validate it, get it all looking right in a separate staging area. And only then, once it's all cleaned up and ready, do you load it into the data warehouse.
But with modern cloud technology and the rise of big data, that whole model got flipped on its head. Now we hear about ELT, extract, load, transform. You see what happened? You still extract the raw data, but then you immediately load it, mess and all, right into a data lake or the warehouse itself. The transformation part? That happens much later, on demand, whenever you actually need the data for analysis, using the raw power of the modern warehouse.
So when you put them side by side, the difference is all about timing and flexibility. With ETL, the transformation happens before loading. It's less flexible, but it was perfect for traditional, highly structured data warehousing. With ELT, transformation happens after loading. This gives you way more flexibility and is a perfect fit for the giant, sometimes messy, data sets you find with big data and data lakes.
Okay, we've designed our warehouse. We've filled it with data. But there's one last critical challenge we have to solve. The world doesn't stand still. Data changes. So how do we keep our history accurate when the world is constantly changing around us?
Seriously, think about it. What happens when a customer moves to a new state? Or your company rebrands a product and gives it a new name? If you just go in and update the record, you've completely lost the historical context. You can't tell where that customer's sales were coming from last year. This is the classic problem of what's called slowly changing dimensions.
Now there are two main ways to handle this. The first is type 1, just overwrite. A customer moves, you update their address. Simple. The problem? The history of where they used to live is gone, forever. The second and much more powerful approach is type 2, add a new row. Instead of overwriting, you add a brand new record for that customer with their new address, using start and end dates to show which record was active and when. It's more complex for sure, but it means you maintain a perfect historical record.
So, after all of this, the architecture, the schemas, the data pipelines, what's the actual payoff? Why does any of this matter? Well, it's about getting a single consolidated source of truth, so everyone from sales to marketing is finally looking at the same numbers. It's about enabling truly data-driven decisions, so you're acting on real trends, not just hunches. You start to uncover hidden patterns that were impossible to see before. It's about getting a complete, reliable view of your business, past, present, and future.
This quote really says it all. A data warehouse enables organizations to make decisions based on data, rather than solely relying on experience, intuition, or hunches. That's the whole ballgame. It's the shift from just guessing to knowing.
And this all brings us to a big final question about the future. As modern tools like data lakes and cloud warehouses keep evolving and the lines between them get blurrier and blurrier, are we heading toward one single unified system that will eventually rule them all? Or will these specialized tools, each built for a very specific job, always have their place in the data landscape? That's a question the entire industry is trying to answer right now.